Algebra Honors, we're going to take a look at some more problems on the study guide for our final exam. And so we just finished with, I think we just finished with 33. So we're going to start on question 34 right here. So our question 34 says, which of the following values for x will make relation a function? So remember, in order for something to be a function, every single x value has to be unique, or every single point has to be unique. We can't have one x value go to more than one y value. So here's what we're going to do. We're filling in this x. So I'm just going to go through my multiple choice options. If I use 4, I'm going to have 4, 1. Right? That would be my ordered pair. So I have 4, 7 and 4, 1. I can't have that. That would not be a function. So no on the 4, right? Because that means that I have an x value going to two different y's. If I have a 6, then I'm going to have 6, 1. Okay, so I look 4, 7, 0, 1, 7, 2, 6, 1. That, every single x is different, so that works. Okay, it says which of the following values, so there's possibly more than one. So that did work. Now I'm going to look at 7. If 7 is my x, then it's going to be 7, 1. So I have 4, 7, 0, 1, 7, 2, and 7, 1. That doesn't work because I cannot have 7 go to both 2 and 1. So no. And my last option is if x equals 0. So I'm going to plug that in 0, 1. Okay, I have 4, 7, I have 0, 1, and 7, 2, and 0, 1. In this case, because 0 only goes to 1, it's only going to one single y, it's the same exact point. That means that this does work. So both of those answers would work for making relation A also be a function. Okay, so do watch out for that because a lot of times on standardized tests, they do double check that you understand that a single point can be written, shouldn't be written more than once, but if it is written more than once, it doesn't make it not a function. Okay, number 35 then, not number 43. I gotta separate my pages, sorry. Okay, consider the function, there you go, f of x equals negative 4x minus 5. We're gonna determine the value of x when the f of x equals 11. So I know f of x equals 11, so instead of that f of x notation, I'm gonna put 11. So instead of f of x, I'm going to say 11, right? F of x equals 11. So 11 equals negative 4x minus 5. I'm just solving for x. I'm going to add 5 to each side. 16 equals negative 4x. And I'm going to divide each side by negative 4, so I have negative 4 equals x. Okay, just keep track. If they are telling you what f of x equals, that means that's the whole output. If they say what is the value if x equals some specific number, then you're just going to be substituting in for x. Right, 36. The graph of this function is shown below, and I believe there's an issue with this actually. We are going to say that this should say minus 3. There's a typo on here. And I know that because I know negative 3 is my y intercept, right? So sorry for that typo. If this is my function, x squared minus 2x minus 3, and I'm hoping the rest of it is graphed properly, we're hoping so. What is f of 2? Well, I have the ability to look if f of 2 means that my x value is 2. If x is 2, I can see right here that y is negative 3, right? So hopefully this works up here as well. If I plug into 4 minus 4 is 0, and 0 minus 3 is negative 3. So it should work both ways if my equation is correct. If the f of 2 I plugged into 2 squared minus 2 times 2, so 4 minus 4 is 0, minus 3. Okay, next. What is the value of x when the f of x equals 5? That means my output, or really my y value, is 5. So I'm coming down here, and I'm going to say if this is y is 5, look at this. I have an x at negative 2, and I have, this is y is 5 also, positive 4. I believe negative 2 and positive 4 are going to be my answers. And I can also do this mathematically. I know the f of x is 5, so 5 equals x squared minus 2x minus 3. That one I would add 3 to each side, or I would subtract 5 from each side. So I'd have 0 equals x squared minus 2x minus 8. And then I would probably factor that. So if I find the zeros by factoring, I would see that that is x minus 4 times x plus 2, right? X squared minus 4x plus 2x, that's negative 2x minus 8. So I can see that my x's are going to equal 4 and negative 2. Okay, so this is all for B. Now, f of 5, if I plug in x equals 5, I can't quite see it on my graph. So instead I'm going to use the equation. Please note that if you're looking at the key in Schoology, the key uses the original equation, but I'm going to use the real equation, okay? Because I know this is supposed to be x squared minus 2x minus 3. So this answer is going to be different from the key. If I plug in x equals 5, then I have 5 squared minus 2 times 5 minus 3. So I have 25 minus 10 is 15 minus 3 is 12. Okay, so the f of 5 is 12. On the key, it actually said the f of x when x is 5 is 13, only because the person who made the key used minus 2 as part of the equation. I hope that makes sense. All right, number 37. If k of x equals 5x and h of x equals x squared plus 4, what is the h of the k of x? Well, all I'm going to do is I want the h of x when the input is the k of x, right? So if k of x equals 5x, I'm just going to plug that in as my input. So what is the h of the k of x? It's the same thing as saying what is the h of 5x. So any place I have input x, I'm going to plug in now this. So instead of x squared, I'm going to say 5x squared, use parentheses, plus 4, which means that I have 25x squared plus 4. Okay, number 38, composite functions, similar type of problem. So if I know that the f of x is equal to x plus 1 and the g of x is equal to 3x squared, what is the f of the g of x? So the f of the g of x, the input is going to be 3x squared, right? So I'm going to say instead of x, my input is now 3x squared plus 1. That is the f of the g of x. What is the g of the f of x? Well, this time, I'm starting with the g of x equals 3x squared, right? But instead of plugging in x, I'm going to plug in x plus 1. That is my input. So 3x squared, I'm actually going to say is 3. Instead of x, my input is x plus 1, so I'm using parentheses, x plus 1 squared. And of course, I can simplify that. G of the f of x equals, it's going to be 3 times x squared plus 2x plus 1, which equals 3x squared plus 6x plus 3 in the end. Okay? So you are just, whatever your input is, you're just making sure that you are using parentheses and keeping track of your input. My second answer is that. Okay, number 39. I have systems. So this was Unit 5. Unit 5 was systems of equations and inequalities. With equations, we have 3 ways that we can solve. We can solve by plugging in our 2 equations into a graph and looking to see where the 2 lines intersect. Since you can use Desmos on this final, I would say do that. Okay, but we can solve by graphing. We also can solve using substitution, and we can solve by elimination. So if I'm looking at this problem presented this way, and I pretend I don't have Desmos available, if I have to do this manually, I can see that y equals 5x plus 4. So instead of y in my upper equation, I'm going to put what I know y equals 5x plus 4. So 2y, instead of y, I know y is also 5x plus 4. I'm just plugging that in. I'm substituting that in. and it equals 10x minus 4. Okay, see, I literally, instead of y, I said y is 5x plus 4. I'm doing this because now I only have one single variable. And of course, now at this point, I'm going to simplify each side, and then I'm going to get my variables to one side, and then I'm going to solve for the variable. Several ways to do this problem, but probably easiest to say 10x plus 8 equals 10x minus 4. I'll subtract 10x from each side, and I get 8 equals negative 4. Uh-oh. No solution here, right? So what does it mean when I have no solution? It means that if I were to graph these two lines, and I'm not really going to graph them, but I know that any two lines that are parallel to each other have no intersection. Okay, so if I have no solution, it means my two lines are parallel. So if you did plug those into Desmos, it should show you two parallel lines, right? They do not intersect any place. Okay, this was solving by substitution. This is not really graphing because I didn't actually look to see what is my y-intercept and what is my slope and everything. But in Desmos, if you plug those in, you'll see that you have two negative lines. Two parallel lines. All right. Solve this system. I have 4x minus y equals 3 and 2x minus y equals negative 9. So the way this one's set up, I would probably do elimination. So I'm going to subtract the entire second equation from the first equation. So I have 4x minus 2x is 2x, negative y minus negative y is nothing, right? Negative y plus y is just 0. And 3 minus negative 9 is the same as 3 plus 9, which is 12. So I know x equals 6. The system, I need an ordered pair. I need to know what x and y works for both. So I found the x, and if I plug that in to my first equation, I'm going to say 4 times 6 minus y equals 3. So that means 24 minus y equals 3, and that means negative y equals 3 minus 24, right? So negative 21, so y equals positive 21. I need both of these answers in order to share the solution. I have 6, 21 as my ordered pair answer. Right? So that was using elimination because that seemed like it was the most obvious way to do this. Again, if you plug in these two equations into Desmos, you're going to end up with two lines that, and I don't know what the lines look like, but they are going to somehow, is one of them, no, they're going to somehow have an intersection at the point 621. So please realize I'm making up lines. I don't know where those two lines would be in Desmos, but a solution to a system of equations is a single point. If your lines are parallel and you have no point, you have no solution. If you have one single point, you have one single solution that has an x and a y that works for both. And then the other option is you can have them be the same exact line, and then you would have an infinite number of solutions. No matter what x and y combo you put in, if it works for one, it works for the other. All right. So I'm assuming that number 41 is going to give us a system of equations that has two lines that are exactly the same. Looking at this, I would probably do this by, I'd probably do this by no, I wouldn't do substitution. What would I do? I guess I can do elimination. Now, with elimination, you need to make sure that everything is aligned properly. So I'm going to do this first line here. I like to have mine set up so that it's, well, I'll leave it, negative 12 minus 4x equals 6y. I just need to make sure that I have the second information in the same order. So I'm going to put my constant. I have to subtract 18 from each side, right? Minus 6x equals 9y. Okay, notice that I am aligned so that my constants are one on top of the other. My x values, my x variables are aligned, my equal sign is aligned, and my y variables are aligned. So with elimination, if I want to get rid of either the x or the y, let's see, if I divide everything in this purple one by 2, I'm going to divide everything by 2, every single thing. I end up with -6 minus 2x equals 3y. I did that because I'm looking for things I'm going to be able to eliminate. I'm going to divide the entire bottom situation by 3. And so I'm going to have -6 minus 2x equals 3y. Oh, that's exactly the same thing, right? So I was getting ready to do some elimination. If I subtract the whole bottom information from the whole top information, I'm going to end up with 0 equals 0. Always true, right? So we know when we have always true, it's infinite solutions or all real numbers. All real numbers. And also we know that if we were to graph this line, both of the lines really, they're going to be the exact same line. Again, remember, I am just using a line to illustrate that I have a line in the same exact spot. I did not actually figure out what my line's going to look like. I didn't figure out where it was going to cross the y-axis and things like that. Okay? All right, so let's try... Nope, we're not going to try one more. We're going to go ahead and end this video, and I bet there will be 2 more. Thanks for watching.